All right, for lesson 2 of chapter 20, we are looking into something called the correlation coefficient. So this is going to be represented by the variable r. So sometimes they just refer to this as the r value. Sometimes it is referred to as the correlation coefficient. Just be familiar with this phrasing right here, that little vocab phrase, because that's often used, and a lot of times people forget what this is called, and so it comes up on a test, and somebody, there's some question on the test is saying something about the correlation coefficient, and students always call me over and ask me what that means, and so you need to know that is referring to what we call the r value, and simply the r value is this. When we were looking in lesson 1 at a scatter plot, one of the things that we had to describe about this was the strength. And the r value simply tells you exactly how strong the relationship is. And so lesson 2, what we're really getting out of lesson 2 is we're taking this one little idea and going deeper into him. And so that's what the r value is. It just tells you how strong the relationship is between the two variables that are being tested. And so as we look at this, there's two things we need to talk about here. One is, how do you get that value? How do you calculate the r value? And the second thing is once you have it, what does it mean? So once we get the value for r, we need to be able to interpret what that number represents. So first things first, how do you get the r value? Well, there's two ways. One is with a formula. There is a formula for calculating the r value. It looks like this. There are three parts to it, and I listed out what these things are over here on the right. This is something called covariance, which we haven't really talked about, so this is not something that you would come up with on your own. This is something that would be given to you within the problem, and that's what I stated right here in this statement, that this is done by hand only when the covariance is given to you. And I'll show you an example of that here in just a second. The bottom two pieces you're familiar with, though. These are the population standard deviations, and we did those in the last chapter. So if you created a list of data within your calculator and you go into your two variable statistics, because you have an x and a y. So if you created your x's as list 1 and your y values as list 2, and you go into your two variable statistics, you'll find the standard deviation for the x's and the standard deviation for the y values, and you would sub them in for those two variables. And so that's what's going on here. I'm going to quickly show you what this looks like within a problem. So if you take a look at this one here, this is actually page 581 of your book. Now, this is the old book, so don't go by this page. But here's the formula right here. And again, you'll notice for this problem there are two variables, an x and a y. So the x is representing math scores and y is representing biology scores. So we have two variables, and remember, this whole chapter is all about how do these two things relate. Do the math scores have anything to do with biology scores? And so that's what they're really ultimately going for here. So right here, notice they're giving you what we call the covariance. That is the top part of the formula right there. So that's just something that they're telling us what it is, and so you see right here they sub that in to the top of the formula, and so that's just given to us, and you plug it in. The bottom two pieces you would get from your calculator. So if you put the math scores as list 1 and the biology scores as list 2, and you go into the two variable statistics, you would find the standard deviation for the x's and the standard deviation for the y's, and we just sub those in right here and right here. And then we just throw all this into our calculator, and out comes what we call the r value. And so this is the r value, or the correlation coefficient, for these scores for x's and y's. Now, this formula goes even deeper. You can see there is a way of calculating covariance, and that's given right here. So this is how you would actually calculate the covariance. You don't need to do this. You don't need to know this formula for any test question. The only reason I point this out is because for those IB students who choose to do statistics for their internal assessment IB project, if they choose to use this type of a problem, they need to be able to do this formula by hand. And so I always introduce it, but for our class, you don't need this for any test question. your calculator can give you this answer right here. And so I'm going to show you how to do this on a calculator, and that's all you would need for any test question. So you don't need to know this formula unless you're trying to use it for a project as an IB student. So let me go forward to the next part then and show you how you would get the R value or the correlation coefficient in your calculator. So to do this, we're going to use yesterday's or the previous notes list of data. So this was done in lesson 1. So I'm going to use this data right here to calculate the R value or the correlation coefficient for this data, so how closely related it is. And so if you want to do this with me, you're going to go into your calculator here. See if I can get it all on the screen for you at the same time. There we go. So if you go into your calculator, first things first, there is something in your mode button that has to be turned on in order to get the R value. So if you go into mode, and if you go down to the one that says Stat Diagnostics, you got to make sure that is turned on in order for this to work. If you don't have this under your mode button, then it would be under your catalog button, which is down at the bottom of your calculator. So you can find it down there. And again, look for Stat Diagnostics and just make sure they are turned on. Anyway, if you go to what we did last chapter, so go to Stat, go to Edit, and we're going to put the X values in list 1, and we're going to put the Y values in list 2. And so I've already done that, so you can, if you're going to follow along, just pause the video and do this in your own calculator. But I already put those in there as list 1 and list 2. So from there, if you go back into Stat, go over to Calc, and option 4 that says LinReg, that's for the linear regression line that we're going to talk about in the next lesson. But under option 4, if you hit enter, and again, make sure that your calculator recognizes the X's were list 1, the Y's were list 2. Your frequency list should be empty. So just hit enter all the way down. And right there at the bottom of the screen, you see the R value. So here's the R value or the correlation coefficient for this set of data. And so this is the way you can always do it for all of our test questions, is right off of your calculator. We will always round this to 3 sig figs. So 0.969 would be the correlation coefficient for this set of data. So that's the way you can get it for all of your problems for here on out for this chapter, and as well as for the test. Okay, so now that you know how to get it, the second step is, what does it mean? So how do we interpret the meaning of this value right here? So let me go back to another page in your book, and this is on page 574 and 575 of your book. So right here, this is all the main information that you're going to need to know. This is how we interpret the R value. This is what it means. And this is always what you need to know, because the follow-up question after you calculate the R value, the follow-up question is always going to ask, so what does that mean? And so we have to interpret the R value. So here's what it means. So this is a really good gauge. This chart, this green chart, is perfect. So the closer, your R value will always be a number between -1 and +1, always. If it is 0, or really close to 0, then that means your data is not linear. So look at an example like this. This is something we talked about in the first lesson. If your data is not linear, well, then remember we said you weren't even allowed to give it a direction or a strength. Well, if it's not linear, it has no strength. Therefore, the correlation coefficient is 0 or really close to 0. It's just not linear. And so that's how we interpret it when it's really close to 0. But as you go closer to 1 or closer to -1, the stronger R becomes. So if you have, and this is a really good difference right here in these little graphs, but notice these are super closely related. They're very linear. So these would have like a perfect rating of +1 because they go in the positive direction. Just like this one here, these are still perfectly related, but they're going downward, so they are -1. So both of these are cases where R is very strong. These have a very strong relationship. As you move to the right, you'll notice that R gets closer to 0. And that just shows the weaker the data is. So the more spread out your data, the closer to 0 your R value becomes. Whether it's positive or negative, doesn't matter. We're rating it as how close it is to 0 or how far from 0 it is. One thing to keep in mind is a lot of times the way students interpret this is they go from top to bottom, and they assume that the closer it is to 1, the stronger it is, and the closer it is to -1, the weaker it is. Well, as you can see, that's not true. It's the closer you are to 0, the weaker it is. As you go away from 0, whether it's positive or negative, it becomes stronger the farther you get. So keep that in mind. You're always, whenever you describe the R value, notice that we always describe it with two things. The first is how strong it is, so whether it's strong or somewhat strong, or if it's weak. The other thing that we describe it with is a direction, so positive or negative. And so there's always two adjectives that we give these things whenever we're describing them. So anytime a homework question asks you to describe the R value, you need to give it two adjectives. So it's either positive or negative, as well as how strong it is based on where it would fall within a chart like this. And so this is a pretty good model of what you can follow to give it that description. So that's how we interpret it. And again, the R value just tells you how closely related the data points are. So if you look at the one that we were doing and the one that we did on the calculator just a minute ago, we got an R value of 0.969. Notice that is really close to 1, which means the data that we have is extremely linear. And so if we look at the graph that we made for these, again, notice these are very closely related. That's a really strong linear relationship, which is why the R value is so close to +1. And so that's what that means, and that's how we interpret it.